Hello and welcome to this video where we're going to look at a day in the life of a packet. Okay, now first of all, I'm sorry for the noise in the background. That is my dad on the saxophone. He practices a lot and it's hard to synchronize or, get the right time to record this. So I'm sorry for that faint noise in the background. So we're using this Cisco Modeling Labs, and this allows us to run networks virtually using the cloud. And they're pretty much just virtual versions of real devices. So, it's a more I do have physical equipment here, physical routers and switches, but it's all moving towards the cloud these days. The cloud meaning, some data center has computers where these are running, and I'm talking through the internet to the data center, and it just sort of looks like it's all here, but this is just this is just the web interface that shows it all, but really it's happening here in these computers in the cloud, right? So really useful software. I suggest you check it out if you want to learn about networking. So what we're going to do, and first I'll explain this here. We've got two networks, and we've got a service provider in the middle. This would be whatever, Telstra, Optus, AT&T, BT, Verizon, there's tons of them, and we've just simplified it here to one router. In reality, this would be a very complex network. And then this is your network and my network. And we've got simple networks, one router at the edge that connects to the ISP, and then a switch that connects our LAN devices here, a few PCs. And what we're going to do is send an ICMP echo request from 1 to 5, and we should get back an echo reply back from 5 to 1. This is called a ping. If you've heard of this, a ping uses this protocol and sends these messages to test connectivity between two networked computers. Alright, so what we're going to do once the ping goes through is look at each link here where the packet went across, and we're going to analyze the headers, right, and just what's actually going on under the hood. Okay, so I'm just going to double check that it's running here. So if we click this link, we can actually see, yes, we've got a packet capture going. So what I'm going to do is on this PC, I'm going to ping the other side, and this is going to trigger this ICMP protocol. Now the other side's address, I'm on the .1, I'm on 192.168.1 network, and your computer is on 192.168.2 network, and it's specifically .3. So I'm going to ping 2.3. Okay, and we'll press enter, and look at that, we're getting these replies, and that just tells us that it's working. So now maybe if we were going to set up a web server over here, we'd at least know we've got connectivity for ICMP. There could be exceptions where the specific protocol you're using doesn't work because of filters along the way, pretty much just filters, but ICMP basically will at least let you know that you can get a packet, a basic form of network traffic to the other side. Okay, so what do we think is going to happen? Let's find out. So let's go on the link. Now, the first thing we see is the ARP request and the ARP reply. Now, this is where it might get confusing, right? In the ARP video, we learned that when you are going to some destination IP, you need to then resolve the MAC address, right? But we're not actually resolving the MAC address of the final destination we want to go to. We're actually going to resolve the MAC address of our router. And the reason why is, on these PCs, you give them what's called, you type in or you discover it through a protocol, a default gateway. And what that default gateway does is that whenever you need to send packets to a computer outside your own network, you don't need to worry about how you're going to do it, right? You just say, router, here's the packet, you figure out what to do from there. Same with this side, PC5, I've punched in a default gateway, and that points to the router. Then, when PC5 needs to send packets to a computer that's outside its network, it simply sends it to the default gateway, and then the default gateway handles it from there. So, the thing is that when we send this ping, the computer will compare the destination to its own address, and when it compares this 2.3 to 1.2, because its address is 192.168.1.2, you can see that they're in different networks. And remember, we'd always have a mask, so if we write the mask here, let's just say this is a /24 mask. That means this portion is the network and this portion is the host. So same thing this side, the network and then the host. With this mask, it can see that the network portion, that they're different, right? This is 192.168.1 and this is 192.168.2. Therefore, it's sending it to a computer outside its network. And when it needs to do that, remember, it sends it to the default gateway. So actually, it's going to resolve the MAC address of the default gateway first, which is what we see. When we look here, the request is broadcast to the allFs MAC address. So here in the Ethernet header, it's a broadcast. We don't know where it is, so we're just sending it to everyone on our LAN. But the broadcast doesn't go across this boundary. It stays within here. The router is the boundary of that broadcast. Now if we look here in the ARP header, we see that the target is actually, for this ARP request, is actually our default gateway, which is .1. We don't know the default gateway's MAC address. The reply comes back, now we know the default gateway's MAC address. So we've done the ARP and resolved the MAC address for the default gateway. Now if I filter for the ICMP section, which was the actual thing we were doing here, we were sending a echo request and reply. Here we see the first echo request. And now we're actually sending it to the destination of the default gateway for the MAC address. This is something important to know. The MAC addresses along this path are going to change for every hop. So there'll be a certain pair here, and then here, here, and then here. Now this can be a bit confusing. The IP address is going to stay the same for the whole duration. So yeah, bear with me here because it gets a bit tricky now. But the MAC address for this hop, right? We're going from our MAC address to the default gateway. But the IP address is just what we'd expect. It's just going from .1.1.2 to .2.3. Okay, and then here's the actual data, the ICMP, and it's just sending some random string, right? Here's the reply. Here's the data for this, just the random data, and then here we see it's coming back from .2.3 back to us, .1.2. Right, so this is the first hop, and let's just follow the request over each hop. We see that the main thing I want to show you here is how the MAC addresses are going to change for each link we go across here. So just take note here, right? On this link, IP is .1.2 source and destination is .2.3. MAC is these two. Okay. When we go on this link, look at the request, the MAC's still the same. So actually the switch doesn't change the MACs. But once we get to this hop, right, now it's going to change. So now the MACs are actually, the source MAC is this interface and the destination MAC is this interface. When we go to this hop, the source MAC is this interface and the destination MAC is this interface. And when we go to this hop, which includes both these, because the switch isn't changing it, when we look at this next hop, the source, it will now be this interface and the destination will be this interface. So you see how the MAC changes for each hop. So here's one hop, another hop, another hop, and another hop. The source and MACs are changing for each hop. But if we were to look at the source and destination IP for any of those hops, it stayed the same. .1.2, .2.3, let's look here. Right, .1.2, .2.3. So this was something that I struggled with a lot when I was learning about networking, but I hope here I've showed you that the IP for the whole duration, right? So let's draw a line here. For this whole thing, the IP is staying the same. For the whole duration of the packet going there, and then on the reply it's just everything reversed. But the MAC is changing for every hop. Here's one hop, remember the switch isn't changing it. Here's another hop, here's another hop, and here's another hop. And for each of these hops, the MACs change. So you can sort of see now that the MAC is really used to get it across each hop, and then the IP is used to get it like from the full, for the full journey. Okay? So what else we could have a look at is on the other side, when this computer got the request, it needed to then send back the reply, right? And we'll actually see that this computer also did an ARP for its default gateway. In this case, it's .2.1. We see who has .2.1 tell .2.3. So this computer did the ARP as well, because remember, as I showed on this side, when it needed to send something to a network or to a computer outside of its own network, it had to send it to the default gateway. And in order to get it to the default gateway, it needs to know the default gateway's MAC address. And to find that, it does ARP, and it gets the reply. Now it knows that that is the MAC address. So for the reply, this is going to be the same thing as what we're looking coming this way. The MAC addresses are going to change per hop. So there'll be one hop here, one hop here, one hop here, and then one hop here. The IP is going to stay as coming from .2.3 going to .1.2 for the whole duration coming back. Okay, so this was a look at the life of a packet, a ping packet going from one network to another, and we see that how ARP is used and how the ping request and reply goes back and forth between the computers, and how the MAC addresses change per hop, but the IP address stays the same for the whole duration of going between the source and destination. And we learned that the computers are told what the default gateway is, and this is used when they need to send packets to a computer that is outside of their own. Okay, so this is quite a tricky concept to explain, but I hope you get the idea. This might be a video worth leaving comments if you're still confused. So please leave a comment if you have any confusion. And thank you very much for watching, and I'll see you in another video.